Hi, I'm Shwetank. I'm an engineer on the Wi-Fi team. And today, I'll be introducing the Wi-Fi Aware framework and show how you can use it to supercharge device-to-device interactions in your apps. First, I'll set the foundation with a quick overview of Wi-Fi Aware. Next, I'll dive into how you can integrate Wi-Fi Aware in your app. Then, I'll cover how devices can securely discover and pair using the DeviceDiscoveryUI and AccessorySetupKit frameworks. After pairing, I'll discuss how devices can set up Wi-Fi aware connections using the network framework. Once connected, I'll look at how to monitor and optimize performance of Wi-Fi aware connections. Finally, I'll talk about some important next steps. Let's start with an overview. Wi-Fi Aware enables direct device-to-device communication. Unlike traditional models that rely on routers or central servers, this is truly peer-to-peer. These connections are dynamic and on demand. Devices can find each other and form secure links at runtime. Perfect for local, ephemeral experiences like file sharing or setting up an accessory. Wi-Fi Aware operates alongside your regular Wi-Fi connection. That means devices stay connected to the internet and your local network while simultaneously using Wi-Fi Aware. And Wi-Fi Aware is a global standard maintained by the Wi-Fi Alliance. It's cross-platform, interoperable, and can be adopted by any device manufacturer. With Wi-Fi Aware, you can unlock new experiences and allow your apps to seamlessly discover and connect to nearby devices. Some examples include media streaming, high-speed file transfer, accessory control, screen sharing, and if needed, you can do all of these simultaneously. Introducing Wi-Fi Aware, a new framework that enables these experiences on iPhone and iPad. With the Wi-Fi Aware framework, your app can connect to other Apple devices, third-party devices, and even accessories. When using Wi-Fi Aware, your connections are fully authenticated and encrypted at the Wi-Fi layer, can support high throughput and low latency, and coexist with connections to other nearby devices at the same time. To use Wi-Fi Aware, your app only needs to handle two high-level flows. The first flow is pairing a device. Pairing is a one-time setup process that establishes trust and facilitates secure communication. The second flow is connecting paired devices. The system automatically secures the connection between devices, including key exchange and link encryption. So you don't need to manage security protocols at all. And once paired, your app can securely reconnect whenever your devices are in close proximity and actively running your application. This makes connecting back to the device seamless, fast, and secure. Now let's see how you can set up your app to use Wi-Fi Aware. We will start with discussing a central concept for Wi-Fi Aware: services. Services are used for discovering devices and connecting to them. Think of services as specific functionality that your app either provides or consumes from other devices. Before we move on to declaring services in your app, let's first understand a few key conventions for services. A service is identified by its name. Service names must be unique, only consist of letters, numbers, and dashes, and not be longer than 15 characters. There are two parts in a full service name: a unique name, followed by a protocol, which can either be TCP for services using TCP or UDP for services using any other protocol. To prevent collisions between your app's service names and those used by other apps, you can register service names with IANA. Next, let's talk about service roles. Wi-Fi Aware allows for two possible roles for a given service. The first is publisher, where your app hosts the service and acts as a server, listening for incoming connections from other devices. The second is subscriber, where your app uses the service and acts as the client, browsing for other devices to connect to. Your application can simultaneously operate as both publisher and subscriber if required for your use cases. Your application's info plist specifies the services it intends to use. To do this, add the Wi-Fi Aware Services key. This is a dictionary where keys are service names and the corresponding value is the configuration for that service. In this example, the app declares two services, file service and drone service. Each service has a dictionary of configuration properties. To make a service publishable, include the publishable key, and to make it subscribable, include the subscribable key. In this case, file service is declared to be both publishable and subscribable. This is common when building app-to-app use cases. In contrast, drone service is only subscribable, which is a common scenario when developing an app to talk to an accessory. Keep in mind that your app will only be able to publish or subscribe services that have been declared in the info plist. Now, let's jump into some code and see how to access device capabilities and services that were declared in the info plist. Before an application uses Wi-Fi Aware, it should first check if it is supported on the device. This can be done by checking the supported features property of WA capabilities. Publishable services defined in the info plist are made available through WA publishable service. In the example here, a static property file service is defined for convenient access to the service later on. Subscribable services are accessed via WA subscribable service. For convenience, two static properties are defined to refer to file service and drone service for later use. Now that you know how to add Wi-Fi aware services to your app, let's talk about how you can pair Wi-Fi aware devices. Let's start by discussing what the pairing flow looks like to a person using your app. As discussed previously, your app will pair Wi-Fi aware devices prior to using them. Your app can trigger the pairing flow by calling APIs to show the system pairing UI. For the person using your app, pairing then follows a simple process. First, the person will be prompted to select a device from a list of nearby devices matching the parameters provided by your app. Then, the person will authorize the pairing by entering a PIN code provided by the other device. Finally, the system will complete pairing and let the person know when it succeeds. This will make the device available to your app. Once available, your app can make connections to that device on demand without needing to invoke the pairing flow again. There are two system frameworks available for pairing devices: DeviceDiscoveryUI and AccessorySetupKit. DeviceDiscoveryUI is for making connections between apps and from an app to another device. It supports pairing with both Apple and third-party devices. AccessorySetupKit is for accessory makers to quickly onboard their accessory. It is the recommended framework for hardware accessory makers. Let's talk about DeviceDiscoveryUI in more detail. A person using DeviceDiscoveryUI would start by pressing a button in your app's UI to add or select a device. On the publisher side, your app will call APIs to present the advertiser UI, as seen on the left. On another device, your app will call APIs to present the device picker UI, as seen on the right. The browser UI will find nearby devices that match your Wi-Fi aware service and present them for the person to choose. If the person selects an unpaired device, the system will automatically start the pairing flow. When pairing is needed, the incoming request and a PIN code is displayed on the publisher side and entered on the subscriber side. Once the person confirms the PIN, the system pairs the devices. Upon completion, your app can make a connection to the other device. Now that we have seen the device discovery UI flow, let's look at some code. On the listener side, your app will create a device pairing view by passing it the service to advertise. On the browser side, your app will create a device picker view by passing it the service to discover. When a discovered device is tapped, Device Discovery UI will vend a connectable network endpoint to your app. If required, Device Discovery UI will perform pairing before providing the network endpoint. If you are an accessory maker, then AccessorySetupKit is the recommended method to pair with your app. If your accessory uses multiple transports such as Bluetooth and Wi-Fi aware, AccessorySetupKit will pair and set up both at the same time. Let's take a look at the pairing flow when using AccessorySetupKit with Wi-Fi aware. A person using AccessorySetupKit would start by pressing a button in your app's UI to add or select a device. Your app will fill out a discovery descriptor specifying the service and filters to use for discovering devices. It then presents the AccessorySetupKit UI. AccessorySetupKit will find the nearby devices that match your service and discovery filter and present them in the UI. The person then selects the device they wish to set up. During the setup, the person enters a PIN to confirm the Wi-Fi aware pairing. The PIN is displayed on the publisher and entered on the subscriber side. The system then performs the pairing on behalf of the app. Now that we have seen the AccessorySetupKit flow, let's look at the code. To pair Wi-Fi aware devices with AccessorySetupKit, first, create an AS discovery descriptor, where you provide the service name and filters for device properties like model and vendor. Then, present the AccessorySetupKit UI by creating an AS accessory session and calling showPicker on it. The system will take care of the discovery and pairing process. When the pairing is complete, a new AS accessory will be returned, which represents the newly paired device. This contains a AS accessory Wi-Fi aware paired device ID, which is the ID of the paired device. Your app can use this ID to look up the corresponding WA paired device via the Wi-Fi aware framework. The device can be used to initiate connection using the network framework. For more information on AccessorySetupKit, see the WWDC25 session Meet AccessorySetupKit. Now that I have covered how to pair devices, let's explore how your app can access the list of paired devices. Wi-Fi aware represents a pair device as a WA pair device struct. You can get the list of devices using the All Devices API on WA pair device. You can access device properties like vendor and model name, which are learned during pairing. The API can either vend all devices or the ones that match a provided filter. For example, to get all devices matching example Inc. as the vendor name, create a filter as shown here. The list of paired devices for your app can change at any time. For instance, if a device is removed from the settings. Your app can listen to these changes and update the UI and other state accordingly. The framework provides an easy way to do this by vending an async sequence through WA pair device.allDevices. Note that APIs discussed here vend all paired devices available to your app, regardless of whether they are currently reachable or not. Having covered the first high-level flow, pairing, Let us now focus on the second flow, wherein your application will establish connections with paired devices. Before looking at the code, let's first understand the high-level flow for making a Wi-Fi-aware connection. Making a connection requires two devices. One device publishes the service and listens for connections from specific paired devices. The other device subscribes to the service and browses for specific paired devices to connect to. To conserve power, listening and browsing should be limited to the duration necessary for your use case. Once the browser discovers the service and device combination you provided, it will vend connectable network endpoints to the app. Next, your application will review the endpoints and establish connections with one or more of them. The listener receives the connection request and forwards it to your app, completing the connection. At this point, data can be exchanged. Let's explore how to use the network framework in your application to establish a Wi-Fi aware connection. Before publishing or subscribing, your app needs to select the paired devices of interest. In the example here, publisher creates a filter for devices with names starting with my device. Similarly, the subscribers filter is selecting devices with vendor names starting with example link. The necessary parameters are now available to start listener and browser instances using the network framework. To construct a network listener, provide the service object and device filter created earlier. The network listener created in this manner will only accept connections for the specified service and pair devices that match the provided filter. In addition to Wi-Fi aware parameters, your application can configure network parameters and set up the state update handler. Similarly, the network browser is created using the service and device filter from earlier. This browser will only discover paired devices that are advertising the service and match the filter. Having successfully created a listener and a browser, your app can now establish a connection. To begin accepting incoming connections on the listener, invoke the run operation on the listener object. Starting the listener makes your app discoverable to other devices. To start subscribing for services on the browser, invoke the run operation on the browser object. Starting the browser discovers nearby devices offering the service. The browser will return the list of discovered devices as network endpoints to your app. Your app will then review the discovered endpoints and decide if the endpoint of interest is present. Use the Network Connection API to start connections to the desired endpoint. When the connection is set up, the listener will receive a callback for the new connection, providing it to your app. Your application can now exchange data using Network Framework APIs. To conserve wireless resources and power, stop the listener and browser once all the required connections have been made. I have covered all the steps required to make a Wi-Fi aware connection. Next, let's look at how to optimize connection performance for the best possible app experience. Optimizing performance requires balancing throughput, latency, and power consumption. In most cases, the system will apply reasonable defaults. However, if needed, your app can adjust certain connection parameters. One is the Wi-Fi aware performance mode, which influences the Wi-Fi aware duty cycle. The second is the traffic service class, which sets the priority for packet transmission. This defaults to best effort, but can be set to interactive video or voice for lower latency. If you have lower priority data, utilize the background service class to avoid interfering with other traffic. Typically, bulk performance mode is used with best effort or background service class. This combination results in lower power consumption but higher latency. On the other hand, real time is used with interactive voice or video service class. This provides lower latency but more power consumption. Before you decide to use real time mode, consider carefully if it's required for your use case, as it can negatively impact battery drain. In addition to offering tunable settings for connection performance, Wi-Fi Aware Framework also provides an on-demand performance report for each network connection. The performance report includes metrics on signal strength, throughput, and latency. Use this feedback to tune your app's performance. As Wi-Fi connection strength, environmental interference, and device capabilities can vary significantly in the real world, be sure to test how your app performs in busy Wi-Fi environments. Additionally, incorporate connection feedback from network protocols like TCP in your app. Let's delve into some code and see how you can put the tunable parameters to use. As mentioned earlier, Wi-Fi aware connections default to bulk performance mode coupled with the best effort service class. If profiling suggests your use case benefits from another configuration, you can set the parameters on the publisher and the connection instance on the subscriber to configure the performance mode and service class. In this example, the publisher is set to use real-time performance mode and interactive video traffic service class. On the subscriber side, the same configuration is needed on the network connection object that is created by your app. To monitor your app's Wi-Fi aware connection, access the current path and read the performance report. Your app can then take actions based on this report and refine the overall user experience. Now that I have covered all the things you need to build an app using Wi-Fi aware, I can't wait to see what you come up with. But before we go, let's talk about some important next steps. If you are a hardware manufacturer developing a Wi-Fi aware capable device, refer to the accessory design guidelines to ensure interoperability with Apple devices. The guidelines document is available on the Apple developer website. Following the guide allows your device to reliably discover and pair with Apple devices, maintain strong security, and maximize connection performance. The guide is the best resource for building consistent, high-quality Wi-Fi aware experiences. We encourage you to review the Wi-Fi aware framework documentation for additional details. A sample app is also available which shows how to build an app using Wi-Fi aware and how different performance configurations impact app behavior. Finally, if you are building a Wi-Fi aware device, the interoperability guide can help you to create the best possible experience for your users. Thanks for watching.